couple of disclaimers at the beginning of this presentation because every good presentation starts with disclaimers. I've got 5 of them, actually. So the first one is the standard that I have to say. So one of my jobs is as a government contractor with the Department of Energy at a national lab. This talk was created for my own enjoyment, for fun. It's not related to any of the projects that are funding my time. Anything that I say during this presentation is my own opinion, and it's not the opinion of the US government, the Patel Memorial Institute, or Pacific Northwest National Laboratory. Okay, that one's out of the way. Number 2. So this is actually an extended and updated version of a talk that I gave about 4 years ago to the Roanoke Astronomy Club. I have a couple of pictures throughout the presentation that reference a website called findplanet9.com. That's a website that Mike Brown and Konstantin Batygin put up to talk about their theory and talk about some of their results and the search, and apparently it no longer exists. So you'll see references to Find Planet 9, including on the very next slide, but you can't go and find it, at least not at the moment. Number 3, so inside of this presentation, I've included some fake quotes, just kind of intending to get the point across. If there is an actual quote, I will tell you that it's an actual quote, but otherwise just kind of figure that it's for fun and for entertainment. Number 4 is that my screen arrangement is kind of weird right now. So I'm looking into my camera, but you're all up over here and my presentation is up over here. So I'm going to be looking all over the place. Try not to pay attention to me, pay attention to the presentation. And then I guess the last one is that I'm just getting over what was probably the flu from last weekend. And so I might need a bit of a water break partway through. Now, after all that said, we can actually start digging into the presentation. So I've got this divided in kind of 4 parts. And the first part is just giving you some of this background information. It's giving you the idea behind what it is that we're talking about whenever we're talking about Planet 9, because this is, it's a story that I've been following, not necessarily the closest, but something that's been in the back of my mind. Not everybody has that kind of interest or that kind of time, and I want to make sure that we're all on the same page as we get started. So that's the first bit. So what are we going to start with? Let's start with the Kuiper belt, because this is the belt at the outer edge of the solar system, just beyond Neptune, where a lot of the information that we're going to be talking about takes place. This is maybe a little bit of a weird plot to start looking at. It's a little bit odd to try to figure out exactly what it is that this is showing you. So let me give you at least a 2-minute explanation. So here on the x-axis of this chart, wherever my laser pointer went, there it is the perihelion. So this is the closest approach that some of these different bodies make to the sun. Right here at about 30 astronomical units is where Neptune is, 20 astronomical units is where Uranus is, 10 is where Saturn is, and so this is stuff that's all way, way out in the solar system. The y-axis on this plot is the eccentricity. So this is the degree to which the orbits are elliptical. So a 0 is a perfect circle, a 1 is a perfect parabola, and everything else is somewhere in between. So something that's down here near the bottom has a really circular orbit. Something that's up here at the top has just a really wild, crazy, weird elliptical orbit. Each one of the circles that are in this plot represent some object that's out there in the solar system. Some of them in the Kuiper belt, some of them a little bit closer in, centaurs that cross the orbits of Saturn and Uranus and Neptune. But there's a couple of interesting color-coded groups that we can talk about. The first one here is this blue group. And this blue group, if I pull up another image, is kind of the core of the Kuiper belt. So this is maybe a clearer representation of what we see when we're talking about the Kuiper belt. Again, the orbits of the gas giants and ice giants are shown here. So we've got Jupiter's orbit, we've got Saturn's orbit, Uranus orbit, and then right here, right along this inner edge is Neptune's orbit. And then we've got Pluto here in white, kind of circling around a little bit off axis. But you can see that there's this blue group, and this blue group represents about 80% of the objects that we know of inside of the Kuiper belt. These are things that have nothing called a mean motion resonance with Neptune. So Neptune, as you can see from it being right on the inside of the Kuiper belt, is really important to the Kuiper belt because of its gravitational influence. If something has a resonance with the orbit of Neptune, what it basically means is that the object in question is going to be at the same place in its orbit every time or every other time or every third time that Neptune passes by. And that means that Neptune's going to be constantly tugging it in a specific direction. That's going to be something like this red group, which you can see is very nice and linear. There's a couple of other sets that are in other lines. These are the things that do have resonance with Neptune's orbit. And of course, Pluto is one of them right here, the big red circle. So we've got a group that are called Plutoids or Plutonids sometimes. These are things that Neptune is kind of regularly tugging on, and they have kind of wackier, weirder orbits like the orbit of Pluto that's a little bit off center from everything else inside of this Kuiper belt. And one thing that I did kind of intentionally by pulling up this second image is hide the really interesting ones. Well, the really interesting three. So out of all of this stuff, we've got a pretty nice group here in the Kuiper belt between like 50 and 30 astronomical units. But then we've got these three that are way out over here. And that's really, really confusing, right? Why do we have just these three objects from this plot all the way out, completely unrelated to all of the others? Why is the perihelion distance, the closest approach that they have to the sun, just so distant compared with everything else here inside of the Kuiper belt? And then on top of that, their orbits are all very eccentric. They're very much approaching a very narrow, almost like a comet orbit. Instead of something circular like we're used to with respect to the planets. What's actually causing that? And the short answer is, well, hopefully, fingers crossed, Planet 9, but we don't absolutely know for sure. There's three objects that are here. There are more that have been discovered, but the three that really kicked off this whole idea are the three that are listed here. So Sedna is maybe the most famous, the first one that was discovered, and then we've got another one that was discovered in 2012, another one in 2015, and as we've been making more and more detailed surveys of the outer solar system, we're finding more and more and more of these. So let's start with Sedna. So these over here, if the animation is coming through smoothly enough, are the discovery animations of Sedna. This is actually the couple of screenshots that we got from a telescope that are showing us where Sedna is moving across the sky. This image here is what it looks like with the Hubble Space Telescope. So you can see it's a tiny little dot of light. It's not very well resolved. And so what we usually have are these nice artistic representations that show something that's a little bit red, and that is meaningful. It is sort of a reddish object. But the maybe important thing to think about is how crazy weird this orbit is from the side view and from the top view in comparison to all of the other objects in the solar system all the way in here. The kind of takeaway, again, is thinking about that perihelion distance, that distance where this is closest to the sun. If it was maybe a little bit closer to Neptune, you could imagine that at some point in the solar system history, Neptune maybe got some gravitational attraction to Sedna and flung it all the way out into the distant reaches of space. But whenever it comes back in, it would come back in right to that location near Neptune's orbit, and that's not what we see. We don't have something out here that's going to be gravitationally influencing that inner bound of Sedna. And so it's a little bit of a mystery as to how something like this got the orbital shape that it did, and it got even weirder as we started discovering more and more and more of these. There has to be some kind of explanation for why these objects exist, and in 2003, when Sedna was discovered, we had no idea what it might be. So then moving on a little bit further into the future, we've got these two other objects that I talked about, one of them that was discovered in 2012, one of them that was discovered in 2015. And one thing that you might think about is, well, maybe we're finding these things in the sky just by coincidence, right? They happen to be close to the sun at some given time, right? On this plot here, we've got years going across the x-axis. And so here's the year 2000. And in all of these orbits, we've got something that is closer to the sun, something that is brighter, just coincidentally right now in time. And are there maybe a lot of these that are just distributed out throughout the sky that we can't find? Just because they're too faint, they're too far away. We're just coincidentally finding a couple of them that happen to be in one place. And the kind of answer to that is, well, there still is a chance that, yeah, we've got a little bit of a biased distribution because of the year that it is and where all of these things are inside of their orbits. But in 2014 or so, there was a paper that was announcing the discovery of this 2012 VP-113 object. And the two authors of that paper, Trujillo and Shepard, they noticed an interesting pattern with some of these things that they called extreme trans-Neptunian objects, things that just go way, way out again into the solar system, things like Sedna and VP-113 and the other one from 2015. And what they noticed was that these objects all just have a similar group of orbits, and not just one group of orbits, but two groups of orbits that you can see here over on the right side. We've got kind of one wing that's flying off in this direction from the sun. We've got one wing that's flying off in this direction from the sun. And they were trying to come up with a mechanism for explaining why this would be. One thing that they were thinking about is, could there be a massive body, you know, something that's Mars-sized, something that's Earth-sized out in the Kuiper Belt? They hypothesized it, but they weren't able to come up with a good resolution, a good final product that would explain all of these orbits. So 2 years later, we've got the 2016 paper that Brown and Petigan put out that promises that, hey, there could be a big planet out in the outer solar system that could explain all of these orbits. In particular, we're going to get rid of some of the orbits that maybe were throwing off the earlier results because they were in unstable orbits. Let's focus on the ones that are in stable orbits. And when we do that, the signal becomes a lot clearer. It seems like if we're just considering this small number of objects, there's like a 0.2% chance that this is a coincidence. There's a 99.8% chance that we can find something in an orbit that is going to be causing this influence. And so they did a lot of computational simulations, and I can show that on a slide coming up in a second. But after they've done all of these simulations, they came up with this orbit for something that they're calling Planet 9. Calling it Planet 9 because, well, we have to say that Pluto was demoted. We've got 8 planets right now, and so maybe there's a 9th planet. And if it's something big and massive, then we probably should end up calling it a planet and not something weird like dwarf planet. Whoever would have come up with a weird name like that. Again, just one more animation to show you the kind of scale that we're looking at. So here's the terrestrial planets, Mercury, Venus, Earth, and Mars. And we can zoom out again. Here are all of the giant planets. And if we zoom out one more time, we're going to see the orbits of these things that we're looking at on the screen on the right side. So these are way out in the solar system. And the Planet 9 orbital fit that they came up with that would explain some of these orbits kind of oriented in the opposite direction. You might expect that, you know, if something is going to be pulling all of these things over toward the left, then it should be spending a lot of its time over on the left side. But no, it's counter to that. It's over on the right side. Of course, left and right being something that's very difficult to define whenever we're talking about space. So how does all of this work? Well, they went and they did a bunch of math. Here's just part of what they had to solve for as they were going through and doing all of their different computations. There was a talk a couple of years ago, and I'm trying to remember who it was at one of the astrocons who mentioned that, you know, in modern astronomy, we're not using telescopes on mountaintops all that much anymore. We're using supercomputers. And that's what really modeled this theory. Trillions upon trillions of virtual simulation years is what Brown and Petigan did. And they used all of this computational power. They tried a bunch of different potential orbits. They found a bunch that fit somewhat well. They found a bunch that fit really well. There's not just one orbit for Planet 9 that they've thought through. There's kind of a broad range of possibilities. We don't have a really great idea right now of what Planet 9's orbit exactly would look like, and that's in large part because we've just got a very small number of objects that are kind of hinting us in the right direction. That's going to be kind of a theme that we can keep coming back to through the rest of this talk, is making conclusions based off of a small number of samples, which is always a dangerous thing to do. So moving on to the second part of the talk, right? We're talking about this idea of, we've got Planet 9 out in the solar system. We're predicting it using a bunch of math. Why do we think that this is a reasonable approach, right? Why would we accept the idea that we can just predict the existence of a planet by using a bunch of computers? Well, part of the answer is going to be that we can't. It's not going to be something that we can call a planet until somebody spots it in a telescope and says, aha, there it is, I found the planet. But it's at least an interesting theory up to that point. But then really the second part of this talk is talking about some historical background, and you might be able to guess which one I'm probably going to be talking about with respect to finding a planet using math. We're going to start off with Neptune. So what happened with Neptune? So Neptune was discovered in 1846, and it was discovered because we could not figure out what was going on with Uranus. So William Herschel discovered Uranus in 1781. He wanted to call it George at first. That's a whole digression that I don't have time to go into. But after we found this planet, we figured that we can probably use Newton's models that work for all of the other planets to figure out where this is going to be inside of its orbit. And so there was a French astronomer named Alexis Boucard. He had this really nice set of all of the different gravitational influences of other planets and things that might be impacting the orbit of Uranus. And then over here on this side, we've got a table that shows, well, Uranus actually isn't where we expect it to be. Sometimes it's a little bit further ahead in its orbit. Sometimes it's a little bit behind. We've got some plus signs. We've got some minus signs. We don't have an accurate prediction of this orbit. And that is problematic because, well, Newton worked for all of the other planets. And so Bouvard did what any good theoretical astronomer would do. He blamed the observational astronomers for being lazy and sloppy. If you look down in here, I don't know how clearly the French is coming through the web stream, but there's a couple of mentions. You know, the observations of Flamsteed were lousy. The observations of Meyer were kind of lacking. So he's blaming the observations as being a potential source of error. But then you get a little bit further down at the bottom, you know, the very bottom of this page, and he starts saying, well, you know, there's also a little bit of an interesting pattern to this, right? There's a bunch of minus signs in a row, and there's a bunch of plus signs in a row. And so maybe there's just kind of one thing out there, one undiscovered planet that could be a source of this error that we're seeing inside of my magical mathematical model for how Uranus should be traveling across the sky. And so we fast forward a couple years, we've got another French astronomer, Urbain Jean Leverrier. He's doing kind of the similar analysis. He comes up with this model for where he thinks this other object is going to be in the sky, and he puts in some calls to friends at the Paris Observatory, and they kind of laugh him out of the room, and he can't get anybody local who would be willing to try to follow up on this kind of wacky mathematical theory. And so he has to go off and send an email to Berlin, to the German observatory over there. They picked it up, they read through, they said, this looks like an interesting idea to explore. They popped their telescope out at the beginning of the night, and right around midnight, boom, we found Neptune. We managed to discover Neptune with math on the very night that at least the cable was received. If we want to look at these predictions, and actually you can see some of the names that I've been saying, in addition to Leverrier and Bouvard, there was also an English astronomer, John Couch Adams, who was coming up with similar ideas at the time. You can see that his projections for where Neptune would be were kind of all over the place, almost like, you know, make a model and see if it fits, make a model and see if it fits. But here's where the planet actually was, and right beside it is where Leverrier's prediction would have had it, at least as in terms of the ecliptic longitude. Over here is kind of a top-down view of those orbits, and here's the orbit of Neptune and the orbits that Leverrier and Adams were projecting. So the orbit is actually a little bit in from where they were looking. The planet was a little bit off, but not far enough off to prevent the fact that it was discovered on the very night that at least Gale in Berlin got the cable from Paris. And so I'm going to pop up a counter in the upper right, and we're going to say that the success rate for math is 1 for 1. And, well, it's just going to go down from here. So what's next? Let's go back in time again about 80 years, and let's talk about this thing called the Titius-Bode law. So there was another astronomer, and I probably should have looked up whether he was English or French. So this is either Charles Bonnet or Charles Bonnet. And he had a treatise, he had a pamphlet that was basically saying, you know, I'm not convinced that we found all of the planets yet. This is the first of our fake quotes. And so he had this idea, and a couple of years later, we've got the Titius part of the law. So we've got this guy, Johann Daniel Titius, and he said, hey, check out this cool formula that I found. So based off of this idea of let's take the distance that we have estimated between the sun and Saturn, and let's call that 100. Well, if we do that, then the orbit of Mercury is going to be located at location 4. Okay, easy enough. But then we start seeing a pattern of we can get to Venus at 4 plus 3, and we can get to Earth at 4 plus 6, and we can get to Mars at 4 plus 12. We're just doubling this extra factor. So we've got 3, we've got 6, we've got 12, we've got 24, and ignore that for the moment. But then we've got 48, and hey, if we add 4 to 48, that's where Jupiter is. And we double it again, we get up to 96, plus 4 is 100. We already defined that that's where Saturn is. And so obviously something has to be missing from that location in between Mars and Jupiter. There's a quote that comes up a little bit later saying something like, surely the creator of the universe would not leave this gap unfilled. Surely not. That's not quite the direct quote, but I didn't write down what the direct quote was. Something pretty similar to that. To look at what this looks like actually in table form. So instead of going from the 0 to 100 scale, we can narrow it down a little bit to a 0 to 10 scale to match what the actual number of astronomical units are. And so now Saturn, instead of being 100, becomes 10, and Earth, instead of being 10, becomes 1. And if we look at the predictions versus what the actual orbit averages are, it's pretty close, right? We've got something that's off by 3%, 3%, 4%, 4%, barely off to the point where the numbers actually look the same to 1 and 2 significant digits. And so here is, well, unfortunately, what ends up being another coincidence based off of sampling from a very small number of planets. But it's an interesting pattern, right? It's something that might be worth following up on because, well, patterns usually have an explanation. And so now we've got our second Johann. Our second Johann actually just kind of wrote another astronomy book that became popular, and he cited Titius's formula inside of it, and that's how he got his name attached to the Titius-Bode law, basically from writing a book saying, check out what this other guy found. And so we've got this law, and well, next up is 9 years later when William Herschel says, I just discovered Uranus, again, wanting to name it George, but ignore that for the moment. And hey, this also fits that formula. And so if we wanted to extend beyond that Saturn number, well, next up would be 4 plus 192. That should give us the 19.6. And hey, Uranus was at 19.22 overall. So we've got something that's 2% off again. This is just too much of a coincidence to be fake, right? And it gets even better because then we come to 1801 when Giuseppe Piazzi discovers Ceres, and Ceres fits right in that gap where there was nothing between Mars and Jupiter, and it's only 1.16% off. And so mystery solved, right? We figured out that actually something does exist there. Of course, then, a year later, we found another asteroid, and a year after that, we found another asteroid, and now we've got a couple of 100,000 of them. And so, again, coincidence based off of extrapolating from a small number of things. It gets even worse because in 1846, whenever we discovered Neptune, I discovered Neptune, and no, it actually doesn't fit this anymore. We can pop in both Neptune and Pluto, and we can see that now the numbers start deviating wildly from expectations, with the extra fun coincidence that if Pluto was actually Neptune, the difference would be like 1.02%. So going from some massive numbers to, well, let's just eject Neptune from the solar system and say Pluto is the 8th planet, this law still fits. Extrapolation from a very small number of samples being, again, pretty dangerous. So what do we have? We've got now the success rate for math being 1 for 2. This is a really nice pattern, not a meaningful pattern in the solar system. So then we've got planet Vulcan. And I kind of lied a little bit earlier when I said that Newton worked for all of the other planets. Newton didn't really work for Mercury. Mercury's orbit was precessing a little bit more than it should. And we were trying to figure out why. And somebody came up with the brilliant idea of, well, if something was tugging on Uranus and we found Neptune, maybe something inner to the solar system than Mercury is tugging on Mercury. Maybe there's this unseen planet that's really, really close to the sun. And so let's call it Vulcan. There's a really interesting book that I've got the cover of on the right side, The Hunt for Vulcan by Thomas Levinson, that goes into the whole story about this. There were people who claimed that they saw it. Here's an image, correspondence, the supposed new planet Vulcan, where there was an astronomer that claimed, hey, I actually saw Vulcan. It was a dot on the sun that I found inside of my telescope, but then I got tired and sleepy and I went away. And when I came back, I saw that the dot was in a different place. And so we found planet Vulcan. Well, turns out that there actually is no planet Vulcan. We found out in 1905, whenever Einstein came along and gave us relativity, that relativity could explain what was going on with Mercury's orbit. And so the mathematical success rate is now down to 1 out of 3. And because I'm already extending this talk a lot longer than I thought I would, I'm just going to burn through the next couple of them pretty quickly. So we've got one here in 1898. We've got another French astronomer named Babinet, and he said that Leverrier was wrong, and Neptune actually is smaller than we thought, and so there's going to be another planet out there, and I'm going to call it Hyperion. Here's our second actual quote. This is a quote directly from Leverrier, saying that there is absolutely nothing by which one could determine the position of another planet, barring hypotheses in which imagination played too large a part. So that's a 19th century verbal smackdown for this success rate down to 1 out of 4, and we can keep going, right? So now 1850, there was an astronomer at the United States Naval Observatory, and he was looking for a star, and he then lost the star. And another astronomer at the observatory said, "You must have found a planet." And well, it wasn't a planet. It was user error. We just didn't figure that out for another 28 years or so. And we've got another one. So we've got another astronomer, Flammarion, who was looking at 2 different comets, Swift-Tuttle and Barnard 2, and he noticed that, hey, these are really similar orbits. They have really similar aphelia, the point where they're furthest from the sun. Maybe a planet dragged them into that sync. And then another astronomer, Forbes, came along and said, well, I'm going to look at some additional comets, and I found another group that has another set of aphelia at around 100 AU and another one that has some at 300 AU. So actually, this is 2 different planets. And another astronomer, David Peck Todd, who basically said, yeah, I did this analysis too, believe me, and I agree. Not actually real planets, but a nice predecessor to the idea of something with weird orbital shapes out in the outer solar system leading us toward our planet 9. 1900. So we've got a Dutch guy now, Dutch or Danish, one of the two. Lau says that he's been looking at some of this data on Uranus, and Neptune just doesn't seem to be right. And so here are 2 new planets that would help make this all okay. And then we've got the Harvard famous astronomer Pickering, who said, okay, I'm going to start looking for these. Really, he's not doing the looking. All of his famous female staff are doing the looking through all of the plates, but he gets the credit for not finding a planet. Now we're down to 1 out of 7. A year later, somebody else came to Pickering and said, forget about what Lau told you last year. Here's a new model. It's going to work with 1 extra planet. And Pickering starts looking for that 1 extra planet by delegation and still doesn't find it. So we're at 1 out of 8. And these, aren't all of them. These are just some that I'm pulling out. There are all of these different wacky predictions. I probably shouldn't call them all wacky because some of them were based off of some decent math, but they were all wrong conclusions in the end, right? This one maybe is the one that we can ridicule because there was a quote that I found on this guy's Wikipedia page saying that he is an astronomer with a reputation as an egocentric contrarian. And so he says that, yeah, there's definitely 1 more planet out there and most likely 2 and possibly 3, but he only named 1 of them. And we're going to come back to one more. There was another projection saying, hey, there's another Uranus-sized planet out there. I'm going to name it Hades. This is Theodor Grigol, who came up with this idea in 1902. And then apparently 19 years later, he checked his math and said, well, actually, it's got a slightly smaller orbit than what I was originally anticipating. But again, still nothing that actually exists in the solar system. So we're at 1921. What happens next? Well, we've got Pluto. Pluto happens next. So 1930, we discover Pluto, and Pluto, as you can see, astronomers have hailed this finding. This sphere that was possibly larger than Jupiter met all predictions. We mystery solved. We did it, everybody. Of course, it didn't actually solve all of the projections. This is just a very, very lousy Associated Press article that was announcing the discovery. Here are the discovery images. You can see that here's a tiny little dot right above where my laser is, right beside this arrow. And here's another version of it all the way over here. And that looks like a tiny little faint dot, right? That doesn't look like a sphere that is possibly larger than Jupiter, regardless of it being 4 billion miles away. So I went to a talk that Mike Brown gave at Penn State I don't know, 2015 or so. And one of the explanations that he gave, but I haven't been able to see anywhere else, is that, well, we can explain this because Pluto could just be really massive, right? What if it's made of a core of solid uranium, and then it's got this liquid oxygen ocean that's focusing the light down so that it looks even smaller than that? Of course, that's before we realized a decade later that a core entirely made of uranium would probably be a bad thing. And so, well, Pluto's definitely not just made of uranium. It's only off by a factor of 50,000 from the size of Jupiter, though, so we're still close enough, right? Mystery solved. Well, actually, before I go to the next slide, here's my hand showing one of the discovery plates for Pluto back when I was visiting Lowell Observatory, also, I think, in 2015. Anyway, weird coincidence. So Pluto, well, at the beginning, we thought that it was going to be a fairly massive thing. And then once it was finally observed, it gets a little bit smaller, and then new projections make it a little bit smaller, and new projections make it a little bit smaller still, all the way up until 1978. At 1978, a couple of astronomers, Christie and Harrington, discover that Pluto has a moon. And now that we know that Pluto has a moon, instead of just kind of guessing based off of its brightness, we can use actual physics and figure out that, no, Pluto is tiny. All the way down here, you know, their estimate was that it was something like 1/500th the mass of Earth. It's been upgraded since then all the way to 1/459th the mass of Earth, which is not a huge improvement. There was a joke I read in a book at one point that if we extrapolate this curve from where Pluto was originally projected down to where it was in size whenever we found its moon, Pluto would disappear by 1985. You know, there's another example of let's extrapolate from a small number of sample points. Pluto didn't actually disappear, in case you were curious, but it did, you know, projection size get smaller and smaller and smaller based off of new evidence until we've got something that is, well, the size of a bunch of other things that are out there at the same point. Or near the same point in the solar system, which is a digression for why Pluto actually got demoted that, again, this presentation doesn't really have the time for. But Pluto, well, that didn't solve our problem that we were trying to find with all of these outer planets. And so, well, Pluto takes our success rate down to 1 out of 11. And it gets worse from there. So 1972, Brady is looking at Halley's Comet's orbit and found some irregularities and said that, well, you know, if we had another thing that was Jupiter-sized at 59 astronomical units and was in a retrograde orbit, this could explain these weird things that I'm seeing in Halley's Comet's orbit. And of course, some people later said, well, you know, it's a comet, right? It's got ice and dust that jets out all the time. It's not going to have a nice constant orbit. And so 1 out of 12. 1983, so we had an infrared satellite that we launched, and they said that, hey, we found another planet out there. It's another Jupiter. It's hanging out in Orion, really, really far away. Made all kinds of announcements inside of newspapers. Of course, the lead scientist on the project has an actual quote saying, all I can tell you is we don't know what it is. Turns out that it was an unusually bright galaxy, so 1 out of 13. We could just keep going, right? So there's this idea of Nemesis. It's a red dwarf star or a brown dwarf star that's way, way, way out in the solar system. And, you know, every 26 million years or so, it goes through the Oort cloud, and that sends a bunch of comets that cause extinctions on Earth. And hey, it just happens to turn out that we had an extinction that killed the dinosaurs. And then 26 million years after that, we had another extinction. And, well, this was right after the paper from Alvarez that first hypothesized and later proved that it was an asteroid that hit the Earth around 66 million years ago. But there was another extinction event that came after that at the Eocene, Oligocene. I'm gonna never pronounce that right. Oligocene era, not as huge as a dinosaur wipeout extinction, but another big extinction event. But there's no red dwarf companion to the sun. We've got another one saying that, hey, the comets that are coming in from the Oort cloud should be randomly distributed, but we found a bias. And so there's going to be this planet that we're going to call Tyche that's, you know, 500 times further out than Neptune. We've got another guy named Murray who actually predicted that, yeah, that sounds about right to me. And actually, I think it's even in the constellation Delphinus right now. It's definitely something that's been disproven. And, there's an interesting feature that you might have noticed about the Kuiper belt all the way back at the beginning of this talk, saying that, the Kuiper belt just kind of has this abrupt edge at the outer side. And it would be interesting if there was something Earth or Mars sized in an orbit there that was kind of constraining the outer edge of it, something else that was disproved. And this is where this counter is going to end at a success rate of 1 out of 16 for math. We've got some other projections that have happened since then, but these are now getting to recent projections that haven't been disproven, something that hasn't been ruled out yet. And that includes the Planet 9 prediction. So the takeaway to take from this part of the lecture so far is, hey, we've got this mathematical technique. It seems like it's a really great convincing argument, 0.2% chance that Planet 9 is fake. But we've also got this history of coming up with claims from very small sample sizes and not being correct about them. A couple of claims, about this Kuiper cliff idea. This astronomer has some simulations showing that something that's, about half an Earth mass, from Mars sized to almost Earth sized, could explain the Kuiper cliff and could also explain Sedna and that 2012 VP object. Not something that's been ruled out because the size is small enough and the orbit that's projected would be distant enough that, well, it could actually be out there. There were a few others, the Trujillo and Shepard paper that I mentioned, trying to come up with a fit whenever they were discovering 2012 VP 113. There's another paper that came after that with two astronomers, brothers named De La Fuente Marcos, along with another guy, Arseth, saying that, after the Planet 9 paper came out, they said that this isn't going to cause enough stability in these orbits. We need a Planet 10. We might need a Planet 11. Another planet saying, what about another Mars-sized planet, but maybe up to 2.4 Earth masses, because that's not a small range at all. That could be something else that's out there. And so you might a little bit be wondering what's currently ruled out. And here's what's currently ruled out. So the WISE telescope, another infrared telescope, says that if there's something that's Saturn-sized out there, it has to be more than 10,000 astronomical units away. Something that's Jupiter-sized out there has to be at least 26,000 astronomical units away. But Saturn and Jupiter are pretty big. And so we've got another astronomer, Lorenzo Iorio. He did some simulations based off of what we know about the orbits of Earth and Mars and Saturn. We know the orbit of Earth very well for obvious reasons because we're there. But we also know the orbits of Mars and Saturn really well because we have spacecraft there, or in Saturn's case, we had a spacecraft there for a really long time. We were beaming radio transmissions back and forth. And as a result of that, we know the orbits of those two planets really, really well. And so we've got some projections about how big something could be and how far away it has to be in order to not have an impact on these orbits. So that finally wraps up part 2 of the talk, which of course, again, I rambled on a little bit too long about. So let's speed through some more stuff. Let's talk about the science of Planet 9. So the first evidence that we're going to have talking about Planet 9 is just some basic statistical evidence. And the basic idea here is that what's the most common exoplanet that we found so far? It turns out that it's something that is right around 10 Earth masses, and some of the early projections about Planet 9 said that it was going to be a 10-ish Earth mass planet. And right now, our solar system doesn't have a 10-ish Earth mass planet, right? Uranus is like 15 times the mass of Earth. Neptune is 17 times. So we've got some that are close, but they're still 1.5 to 1.7 times that size. And wouldn't it be really weird if our solar system didn't have the most common type of exoplanet that we've discovered around other solar systems? It's not the best evidence, but it is some interesting statistical evidence that, hey, we're finding all of these things elsewhere. Why don't we have one? But here's some better evidence. So in science, one thing that's really nice is after you make a hypothesis, you find new ways to test that hypothesis. And as Brown and Patigan were doing some more of these orbital simulations, they found out that, well, Planet 9 doesn't just cause this kind of bi-wing pattern with two groups of outer distant objects, but it also has these other two wings that are basically like polar orbits around the solar system that are flinging things way, way out, 90-degree orbits from everything else. No other reason why they should exist aside from Planet 9. They had no idea if any of these things were actually real, and so they went back into the back catalogs, and hey, it turns out that there are a couple of things that have orbits that look like this. So that's some pretty good evidence, right? We have this new prediction, and we verified that, hey, Planet 9 is something that could cause this, and it is something that really exists. So that's great news. Centaurs. So there's this group of, again, outer solar system objects. The centaurs are things that come a lot further inward into the solar system. And if we're just considering the stuff that's, really far out, the stuff that has orbits that stretch really, really, really far out, there was another paper in 2017 that demonstrated that very much like we've got a bi-wing design for these things that are way, way out there and affected by Planet 9, some of these centaurs that are, way out there, but not super, super far away out there, actually have a very similar bi-wing design. And so they're not arguing for the existence of Planet 9 in their paper. They're basically just saying, well, here's another interesting coincidence, right? This is something that mimics what Brown and Batigan were talking about. One more interesting one would be the sun is tilted, which maybe isn't something that everybody really knows. With respect to the ecliptic, the sun is tilted by 6 degrees, and it doesn't really make sense why that would be the case because, well, if we're looking at the normal theories for how the solar system formed, everything should have been forming in the same direction that the sun was spinning. Something weird would have to happen to knock the sun 6 degrees out of alignment. And so an undergraduate student looked at some of the orbits that were projected for Planet 9, and they found that in some of these cases, an orbit for Planet 9 over the age of the solar system could exert enough force in the right direction to tilt the sun by 6 degrees. Of course, there were also other projected orbits for Planet 9 that did not tilt the sun by 6 degrees. So it's interesting, but it's not something that is hugely overwhelmingly convincing, right? If you've got one example that comes out with 6 degrees and another one that comes out with 1 degree, you might not want to put all of your chips on the 6-degree orbit. If there is a Planet 9, though, we have to explain how it got all the way out there. And again, this is, let's assume that it exists. If it does exist, how did it get out there? And there are kind of 3 broad theories for why that would happen. The first is the outward scattering theory. So the idea here is that in the early years of the solar system, there was a lot of orbital instability. Things were changing orbits. Neptune and Uranus swapped places at one point. Jupiter and Saturn got into a resonance. And the best way that we could come up with a computational model that ended up with the solar system that we have is if there was an extra gas giant, ice giant planet. We had 5 instead of 4. And during all of this weird interaction, this one planet got ejected outward. Well, what if that's Planet 9, right? We've got some potential simulations that could show that something could end up in an orbit like that after being ejected out of the solar system. If there's also a lot of gas and other debris that's way out there that could slow its orbit down a little bit as it's flying outward and maybe get it a little bit more of a rounded, distant elliptical orbit. Another theory is the external capture theory, and this one is basically saying, well, if the sun was formed in a nebula, a lot like all of the other stars that we see, it had a bunch of neighbors, and it probably had a bunch of neighbors that also were developing planets, and maybe one of these neighbors got a little bit too close and we stole one of its planets. And so they had another paper that did a bunch of simulations. They found different ways that we could capture a planet, and some of those overlap with the orbits that were projected for Planet 9. And then the third is that, well, it just kind of formed out there, right? And that's something that's pretty low probability. This is definitely not the leading theory because it's just going to take an awful long time to clump together enough stuff all the way out there to get something that is 5 or 10 times the mass of the Earth. But some simulations do give you the ability over billions of years, tens of billions of years to form something that is 10 to the 4th kilometers in radius that would be about Planet 9 sized. So possible, but also rather unlikely. Another interesting thing that we might want to think about is if there is a Planet 9 out there, is it a planet? We have this definition of a planet that was adopted whenever we demoted Pluto that said it has to be orbiting a star. That's true. It's going to be orbiting the sun. And it has to be massive enough to be rounded by its own gravity. And well, that's going to be true because it's supposed to be 5 or 10 times the mass of the Earth. And the Earth is massive enough to be round. So this thing has to be. But then we've got the thing that really knocked Pluto out. It has to be able to clear its orbit of other planetesimals. And this is, kind of a hazy explanation, kind of a hazy part of the definition. What does it mean for something to clear its orbit, right? We've got comets that fly through the solar system all the time. They cross Earth's orbit, so therefore Earth isn't a planet, right? And so we have to quantify, how much mass is okay to still be in a similar orbit or in a crossing orbit. And so here's a paper that defined a metric that shows a couple of different measures that we could use to separate things that are dwarf planets from things that are actual planets based off of what the size of their orbit is and what the mass of these bodies are. And if we extrapolate outward, it turns out that Planet 9 is above the planet line. And so, hooray, if it is out there and it is of the size that is estimated, Planet 9 would be a planet, at least under this explanation. But of course, the big important thing is that if somebody does find something out there, we'd have to actually go back and see, did this thing that was discovered actually match the Planet 9 theory? It needs to be able to match not only the data that it's trying to explain, the orbits of these different things, but it also has to have the right mass and the right orbit to be able to dynamically sculpt the solar system so that we get exactly the observations that we have for all of these other orbits for outer solar system objects, and not any of the other possible orbits that could also be out there. So not everybody agrees that Planet 9 could exist. And so there are questions about, well, what if that 0.2% chance is correct, right? Here's another paper that Brown and Batigan put out talking about orbital clustering in 2018, and they confirmed through a different set of analysis that, hey, it's like a 0.2% chance that this is a coincidence. There is a 99.8% chance, given the clustering analysis that we're doing for all of these orbits, now given the fact that we've discovered a couple more of them, that Planet 9 should be out there, that Planet 9 is the thing that is gravitationally causing this pattern in the outer solar system. And some other simulations come up with similar ideas, right? So there's a paper here that I won't go into too much detail about because, again, already rambling on long in this talk. But here's a probability of finding two extreme trans-Neptunian objects that have very, very similar orbits. The probability that it is just by chance is 0.000205. And their paper concludes that these findings best fit with the notion that not necessarily Planet 9 exists, but that some trans-Plutonian planet exists. But then other simulations, well, are finding other things, and other studies are finding other things. So here's one from 2021, where they're considering another group of 14 of these extreme objects, and they look at the same kind of statistics that Brown and Batigan were looking at, and they say that their sample is just kind of consistent with a uniform distribution in both the little omega bar, that's the longitude of pericenter part of the orbital numbers, and the big omega is the longitude of the ascending node, where the planet is in the sky when it crosses above the ecliptic. They find that there's no evidence for clustering. And so if there's no evidence for clustering, then we don't need an explanation for why these things cluster in the sky. Again, lots of extrapolation from very small numbers of things. In this case, a little bit larger number of things. We're up to 14 now, but that's still not great for statistics. There's other theories, though, for Planet 9, right? Is Planet 9 a ring of other icy bodies? So we could model the fact that, well, maybe there's not just a Kuiper belt, but there's like a super Kuiper belt, something that's out there, that has like 20 Earth masses and is something that's like 100 to 200 astronomical units out. And that would be something that explains what we see with the Kuiper belt and some of these distant objects. But now we're basically saying that our explanation for why there's a ring of Kuiper belt objects is because there's also a bigger ring of Kuiper belt objects. And, well, you could just kind of go on from there. What if Planet 9 isn't a planet? What if it's a primordial black hole? Pulling this one up in part just because their paper had a figuring side of it that showed what the size of a 5 Earth mass primordial black hole would be. Obviously, it's going to be a different size on your computer screens than it is in the actual paper, but you can imagine that, hey, here's the size of the figure text underneath it. We've got some things that are maybe a little bit wackier ideas. There's this kind of theory that goes that dark matter isn't actually real. It's just that gravity is different over long distances. We call it modified Newtonian dynamics. There's only kind of a small group of true believers who believe in it at this point. But here's a paper that says that if modified Newtonian dynamics is real, then we can explain everything about those outer orbits without a Planet 9. So it's messy, right? There's just not enough evidence really at this point to say anything one way or the other, unless we could find it. And that brings me into the last part of the talk, which I promise is going to go a little bit quickly, and that's the search for Planet Nine. So as we're looking for things way, way out in the solar system, we still are kind of following the same approach that we used for discovering Pluto all the way back in 1930. We take pictures of the sky and we look to see if anything moves. The one on the right is Eris. That's the object that is like 1.3 times the mass of Pluto and directly led to the demotion of Pluto. The one on the left is Pluto's discovery plates. Have fun and see if you can see Pluto actually inside of those plates, if you remember where the arrows were. But if something is moving across the sky, we have to, well, first prove that it's actually a real thing, and then we have to figure out what its orbit looks like. Because if something is really slowly moving across the sky, well, what if it's close by? What if it's an asteroid that's just starting to go into a retrograde motion or just starting to come out from retrograde motion? It's going to look like it's not moving very fast, and so it looks like it's really far away, but it turns out that it's not. Or what if this is something that is coming right for us, and so it's side-to-side motion is very small, but it's moving right toward your face motion is pretty quick. It's something that would look like it's moving pretty slowly across the sky. I promise there's nothing coming to impact us that we've discovered so far. The search for Planet Nine right now is making use of the Subaru telescope, which is up on Mauna Kea in Hawaii. It's nice because it's a very, very large telescope. It's got an 8.2 meter mirror, so 320-inch mirror for this telescope. It's a Ritchie Chrétien telescope, and the fun story associated with our club, if you haven't heard it yet, is the main primary mirror for this telescope was fabricated by L3 Brashear in Pittsburgh. The way that the telescope is designed, they need a hole in the back of the primary mirror that light can redirect through after it goes off of the secondary. So they had to cut a big hole in their mirror, and they asked our club if we wanted it, and we said, yes, please. And so after they polished it, that's the mirror that's in the back of the Manga telescope up at Wagman. Tom Ryland tells the story a lot better than I do, so that was the really, really quick version of me trying to get through the rest of the talk really, really quickly so you're not all bored and leaving the meeting. Orbits. So if we're trying to figure out exactly where Planet Nine is in the sky, if we're searching for it, there are these kind of 6 numbers that define an orbit and where something lives inside of its orbit in the sky. The 2 that are the most important are usually the first 2, the longitude of the ascending node and the inclination, because we want to know how much the orbit is tilted and in which direction is it tilted, especially true in the outer solar system whenever we've got things that are flying around the sun at all kinds of angles. And then after that, well, some of the other numbers can have a little bit more variability associated with them, which is what we found whenever the Brown and Batigan were trying to do some of those initial Planet Nine simulations. So here were the numbers that they came up with in their initial paper. The couple that I can point out really quickly. So the inclination, about 18 degrees. So that's the amount that the orbit is tilted with respect to all of the other planets. Turns out that that's actually about the same tilt as Pluto, which is another coincidence based off of 2 objects. Longitude of the ascending node is also interesting because that kind of tells us where this object would be at the point where it's rising up above the ecliptic. And it turns out that that is in kind of like the Orion-Taurus area. More on that in a second. But they had a lot of variability for some of these other numbers, right? Orbital longitude, semi-major axis, the eccentricity of the orbit. There was a lot of variability. There were a lot of different potential orbits for Planet Nine that could fit their model. They refined them a lot more over time, though. I mean, they've been working on this problem for 9 years, and so they're still running more and more and more simulations using these different kinds of orbital parameters, taking into account new discoveries in the outer solar system to try to refine some of their predictions. And so at the end of the day, they're refining these numbers, and I'll show you a little bit later on some of the other up-to-date numbers, but they're not too terribly different from some of these early ones. So then where is Planet Nine going to be in the sky, right? Where is it going to be overall? Well, the image here on the right side is the orbital track shown across the sky of something that looks like it's moving pretty slowly overall, right? Here's a position in 1940. Here's a position in 2060. You can see here's the kind of head of Cetus. Here's the big angle inside of Pisces. So it's not a very big region of the sky going across 120 years, but it turns out that that's not a Planet 9 prediction. That's for Eris. That's, again, the body that's 1.3 times the mass of Pluto that led us to demote Pluto. But imagine now something that is 10 times further away from the sun than that. That's going to be a crazy, crazy small orbital spiral. And here's a simulation, again, going back to the idea of, well, here's the Taurus area, here's the Orion area. Here is an orbital simulation of 2,000 years of Planet 9 moving across the sky. From 1000 AD to 3000 AD, and these spirals that it goes through every year as it goes into and out of retrograde motion are 6 arc minutes across. That's half the distance between Mizar and Alcor, if you need a mental comparison, the double star in Ursa Major. So this thing is not moving very fast in the sky at all. Being able to spot it is going to be dependent on how big it is. And that's what we're looking at over on the left side here. And also how distant it is, which is also going to be important. It turns out that those are the 2 axes. We've got the orbital radius, the distance, and we've got the mass, the size by number of Earths. And inside of this kind of shaded area are all of the possibilities that we have for something meaningful that could be Planet 9-ish, right? Anything that's over in this area is probably something that whenever the sun was in its stellar nebula, some other star could have stolen it, similar to the capture idea for Planet 9. Everything above this line is that ruled out by the WISE telescope as we can't have something that big that far out. Everything below this green line is things that aren't massive enough. They would be, effectively dwarf planets. And then this purple line goes back to the orbital modeling of, we know Saturn's orbit really, really well. We know Mars's orbit really, really well. Anything that is large enough or close enough to go beyond this purple line would have an impact that we would be able to see on those planet orbits. And so here's our valid range for Planet 9 in this shaded area. And you can see that there's still some pretty decent variability. Here we're below 1 Earth mass, which gets to be a little bit problematic with some simulations. Here's a place where we're going all the way out to 1,000 astronomical units, which is a good bit larger than some of the simulations, but ballpark, we've got a pretty wide range for Planet 9. But what about where is it in the sky right now? So here's the most recent Brown and Batigan paper talking about Planet 9's orbit. The way to read it, first off, is here's your nice sky map. Blue is low probability and red is high probability. So here's the location in the sky where it probably is. And then we've got a distance chart and we've got a magnitude chart. Again, high probability areas are going to be in red. And so we're seeing, right around here, a distance of 400 astronomical units away is high probability. Right around here, a magnitude of 20 is high probability. For a point of reference for the magnitude, remember that Pluto is like magnitude 14 and it's a logarithmic scale. So a magnitude of 20 is 200 times fainter than Pluto. And if you remember back to those Pluto discovery images, imagine something 200 times fainter than that. But these are the kind of refined numbers in this most recent set of simulations, right? We've got something that is, 20th magnitude, but it could be 24th and it could be 18th. How far is it away from the sun? Still a pretty decent range, 380 astronomical units on average, but could be up to 520, could be down to 300. Perihelion distance, where is it closest to the sun? Kind of similar wide range. Inclination's a little bit better narrowed down. How big is it? Well, no longer something that's kind of 10 Earth masses, but maybe up to 8.4 Earth masses, maybe down to like 4.9 Earth masses. Still something that's going to be in that kind of super Earth dwarf Neptune area. But there are definitely some reasons why we can rule out parts of the sky, and that's that some places of the sky, there have already been surveys that would have spotted Planet 9. So again, what we've kind of got here is like a sky map where we're looking at right ascension along the x-axis. And so this is going the full 360 degrees around the sky. We've got a bunch of different simulated orbits for Planet 9 going along the declination, distance, magnitude, and the orbital speed. And the basic idea behind this is all of the different colors mean some region where Planet 9 could be ruled out based off of previous observations, except for the black regions, which is where some survey would not have discovered it yet, or even more problematic, the red, which is this is inside of the plane of the Milky Way. There's a lot of junk in the sky there, and so it's really, really hard to even conclusively say whether something is moving inside of there or not. We need better, higher resolution, more detailed images. But again, overall, we've got some kind of constrained ideas for where we need to look inside of the sky with that Subaru telescope. Here's a screenshot that I took from a Coursera course that Mike Brown gave. You can see again, here's Orion. Here is the head of Taurus, Pleiades. This is Venus. It's not always there, but it just happened to be in this image. And here's the kind of strip where we're kind of envisioning this is probably not only Planet 9's orbit, but where it's located right now in its orbit. And that's kind of a probabilistic idea that if it's going to be somewhere where we haven't spotted it yet, it's probably out at the outer part of its orbit because it would be fainter when it's really far away. And also because of what Kepler's laws say, whenever it's further away, it's going to be moving slower. And so it would spend more of its time in that part of the orbit. Well, we still have to find it and see. Why haven't we found it yet, though? Because, well, the Subaru telescope is something that a lot of astronomers want to use, and so it gets a lot of requests, and the search for Planet 9 gets like 3 or 4 days a year at taking pictures. And some of those days are cloudy, and some of those days are snowy, and some of those days, it's just impossible to open the telescope up. And of course, we need more than just one picture. We need several pictures that are showing something moving across the sky. And so we knew from the beginning that this was going to be a very slow process to try to find. Projections used to say that, by 2035, we would probably have enough of pictures that we could either conclusively say we found it or we didn't find it. But the last thing that I can wrap up with is, hey, we've got this new observatory coming online. Fingers crossed again this year down in Chile, the Vera Rubin Observatory that used to be LSST, the Large Synoptic Survey Telescope. And the interesting thing about this telescope is that it is going to be surveying the entire night sky every 3 days. So imagine that every single part of the sky that is visible from that part of Chile that's not too low to the horizon is going to get a picture taken of it every 3 nights. It's going to be doing this 825 times in each of its sky locations. It's projected to find, 10,000 supernovae and 1 million new asteroids and a bunch of new Kuiper Belt objects and, fingers crossed, Planet 9, if it happens to be in a part of its orbit where this thing could discover it. And so I've just got a couple more pictures that are showing the Vera Rubin telescope, and in particular, the camera on the Vera Rubin telescope, which was a 3.2 gigapixel camera that is 63 centimeters across, 21 inches across? No, that's way off. 27 inches across, somewhere around there. And the filters, 75 centimeter diameter filters, that's more like 30 centimeters or 30 inches across. Really, really big camera that can take really, really big pictures. Here's an example of what the field of view looks like on that detector compared to the size of the full moon. It's a really, really big telescope. You can see the primary mirror there on the left side, and it's going to really, really help out the search. Again, assuming that Planet 9 is in a part of the sky where we would be able to spot it with this telescope. And so we finally made it to the last slide. What's the conclusion? We've got competing ideas. Is Planet 9 actually out there? We've got Scientific American saying that we might be on the brink of finding Planet 9. We've got Universe Today saying maybe Planet 9 doesn't exist after all. These aren't the conclusions of these two different publications. These are just latest stories. Well, I guess the first one isn't exactly a late story. It's 2020, but there's still a whole lot of debate about whether or not this thing actually exists. What do I think? I'm sure that's a question that I'm going to get. And when I gave this talk 4 years ago, I said, I'm probably like 80% confident that it's out there. Now we're 4 years later and there's still nothing. And so probability seems to go down a little bit. Ballpark confidence, I'd say like 70%, but I'm not absolutely 100% knowledgeable on all of the details of the search. And I'm definitely curious to know what you all think. What your judgment is on the existence or lack thereof of Planet Nine. So that wraps up the talk. I'm going to take a water break, and then I'm happy to get some questions.
Good talk.
Great, fantastic. Love it.
Was hoping to keep it under an hour, and I was close.
Hey, John, do you think a spectrograph of this planet would seal the deal? Let's say that Vera Rubin or Webb or a Webb successor finds the planet, but boy, it's rich with water. That makes it a wayward comet. Or if they find this object and it's got a lot of heavy elements, like the inner planets, would that seal the deal?
Yeah, that's an interesting thought, right? I mean, we know that Pluto has a lot of water ice on it, along with frozen nitrogen and stuff along those lines. And so the fact that it's got a lot of water on it could just be a factor of where it currently is in the solar system and how much time it's spent out there. I think a lot of heavier elements might be interesting. The question would end up being, I guess, does it turn out to be massive enough to be a gas giant, ice giant, something that's really heavy atmosphere world, in which case everything's going to be hidden under the cloud layer and we're only going to see methane clouds or hydrogen clouds or something along those lines? Or is it going to be more of a rocky, icy super Earth where we would be able to see some of those, iron or nickel or something else along those lines in the spectrum? That's a really interesting thing that I haven't really thought that much about.
Thank you. Rick Bolanek.
Yes. Hello.
Well, we can't hear you, Rick.
I'm not sure why.
You were faint, but lean in a bit.
Is this better?
Yes.
Okay, I just sent a thumbs up, so I wasn't asking a question. Sorry.
No worries.
It looked like you raised your hand.
Oh no, that's just a thumbs up.
There's an effect you can send thumbs up or hearts or whatever.
Sure. You see
And,
it?
we like the talk.
Yes, absolutely.
While I'm here, anybody thought about naming this thing, assuming they find it, which is a big assumption?
Yeah, I mean, we in some of the planet proposals that turned out to not be real, there are a number of interesting ideas, right? Hades or a nemesis could be interesting. I think the discovery is going to be kind of interesting because who gets the naming rights usually ends up going to the discoverer, but is the discoverer the person who just happens to be looking at the LSST image at the right time? Or does the credit go to the theoretical discovery? We still kind of credit Neptune's discovery to Leverrier because he mathematically predicted it. He wasn't the one that actually saw it first. And so who gets the naming rights? And I guess even on top of that, they just kind of get the suggestion for a name, not necessarily the final say in what the name would be. I think the International Astronomical Union rules do say that it would need to be a Greek or Roman god, likely a Roman god, but at the same time, have we used all of those already in naming asteroids and things? Do we have to go more creative?
There were a lot of them. How
Yeah.
many of us, every time we heard Planet Nine, were mentally tacking on from outer space? I know I was. Please stop calling it Planet Nine.
Plan it.
I got two.
Nine
I got
from outer space. Every time I heard you say Planet Nine, John, I'm like, yeah, mentally, it's like outer space. Yeah.
Yeah.
Well,
Yeah.
yeah.
I got two names I could just suggest for them.
No, not tonight.
Yes. Ugoth from HP Lovecraft and Slow Year from I don't know who.
I don't know. Personally, it should be George. That's a great
George.
planet name.
George.
You win.
George's star.
Well, again, let me throw the question out to you. What do you think? Does Planet Nine from outer space exist?
Morpheus comes to mind for me.
Yeah, John, I have a funny feeling there's a lot. If we find there's going to be a lot of other ones because they're just so far out. They're not illuminated very well.
Yeah.
Space is so vast.
And Mary, don't you have to be of a certain generation also to have Planet Nine from outer
Outer
space
space.
come to your mind
I think
immediately?
so. I'm, so now I'm going to think about my brother Jim again because he was such a movie and science fiction buff. Yeah, if you guys weren't here before the meeting, I lost my brother Jim yesterday. He turned
Oh,
65 3 weeks ago. This was sudden, unexpected, a horrible shock to all of us. And then my brother Tommy had to go out and tell our 100-year-old mom today. So
terrible.
yeah, I'm a little reeling right now from this. Yeah, he had an infection. He was at the hospital in the morning, and this is something he'd had before. They sent him home with antibiotics, and he was fine, and his wife said, okay, let me go to work for a couple hours. And when she came home, she found him collapsed on the floor. So, which is really sending me into flashbacks of Keith, of course, and of our dad. So
Tough situation. Hey,
Yeah.
John, where's Planet Nine relative to the Oort cloud?
It would definitely be very far in. My kind of mental recollection is that the inner Oort cloud is something like 5,000 astronomical units, maybe 1,000, something around there. But definitely, I think the numbers that I showed were like a 380 average for where Planet Nine would be. So, it could have some decent gravitational impact on the inner Oort cloud, but it's well within at least the speculated inner bound.
Right.
Okay. So somewhere we may be able to eventually know that it's there, right?
Right.
All right. Maybe not. So space is big, really big.
I'm 50-50 on it. It would be really cool if it was there. But then there's, like Eric says, there's probably all kinds of neat stuff we can't see yet.
So we don't know what we don't know.
Yep.
But it's good that people are looking, So we are a curious bunch, So.
Alrighty. Since we kind of went a little bit over, which is totally fine. John, thank you very much for being our presenter this month. I'm sorry to hear that you were sick. Thank you for getting better so you
Yeah,
can do
it
the
happens.
talk. Why don't we go ahead and take a 5-minute break if that's okay with everybody? I know normally we do 15, but just because we went a little bit over. So yeah, so we'll reconvene for the actual meeting in about 5 minutes. If you guys have further questions, I'm sure John would be happy to respond to you guys. I can keep the chat open after the meeting a little bit longer if need be, or you could probably also email John. So, all right, so we'll meet back here in about 5 minutes. Thank you, everybody.
Hey, thanks, Kristen.
So I went ahead and put the PowerPoint up. Can everybody see it?
Yes.
Yep.
Okay, perfect. Alrighty, so let's go ahead and get started. It is 8:50 p.m. on January 10th, 2025. I'm going to go ahead and call this meeting to order. On my tab, it looks like there's 39 members present. So let's go ahead and get started. So our last general meeting was in November, which was at Allegheny Observatory. However, we did have the holiday party December 7th. For those of you that were able to join, I believe it was a very, very nice turnout. I was going to get to that at Old Business. However, while we were at the holiday party, we did go over and approve November's minutes. So, Rich, I know we were kind of in the middle of the party. Were you able to take any notes down from the December meeting?
Yeah, I just have some brief stuff.
Okay.
First, I want to amend the November meetings. I made a mistake on the November minutes. I had stated that Ken Coles offered to host the February business meeting at the IUP Planetarium, but that is not what he said. He offered to invite members some weekend in the spring for a planetarium show, but not for the business meeting. So Ken said he will put an update out on that a little bit later, but our business meeting will be either online as it is now or hybrid local. So I just wanted to amend that. For December, a bunch of people were in attendance. I don't have the exact count. The previous minutes were read and approved. Kristen thanked everyone for coming and supporting the club throughout the year. She gave an update to the group on the recent changes in Wagman's leadership and building maintenance. And we also announced the service award winners. Fred Klein won the Brashear Award. Gene Leese, Patrick Reiger, and Steve Rocco won the Lindblom Awards. Becky Nichols, Joyce Osborne Fisher, and Heather Panet won the Harrison Award. And Chris Morford, John Stump, and Luis Rodriguez won the Nova Award. A special citation was presented to Tom Ryland in honor of his years of service to the 3AP and Wagman Observatory. And Dave Rager presented Kristen with a metal print of the Horsehead Nebula as a thank you from the club for all of Kristen's efforts for the year. The meeting to adjourn passed unanimously, and then celebrations continued.
All right. Thank you, Rich. May I get a motion to accept the general meeting minutes from December 7th, 2024?
So moved.
I was first.
Rock, paper, scissors?
Yeah.
Okay. I think Eric was first, and then John Diller, do you want a second?
Yes.
Okay. All right. All those in favor, please say yes or thumbs up.
Yes. 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 Yes.
Yes.
All right. Are there any objections? I guess give thumbs down or say no. Okay. Any abstains? All right. All right. Motion passes. Thank you very much. Rich, those were really quick meeting minutes. All right, I'm going to go ahead and turn over to John Holtz for a look at that. John, I do have your slides up on another PowerPoint if you want me to use mine, or I can give you control if you want to use your computer. It's up to you.
Yeah, why don't you just bring it up since you have it already?
Okay. All right. Give me 1 second here. Let's see. There we go.
Here it comes.
I'm finally getting a little bit quicker with this now. All right. And then,
Practice makes perfect.
all right, should be popping up any second.
Yep, we see it. Go ahead to the first slide.
Look at that.
Okay. So go to the next one.
Yes.
Okay.
So list of upcoming events, and let me just mention that in case it's never been obvious, in this list, the items that are highlighted in yellow are things that I think are worth making an extra effort. And as I was compiling this, it's like, wow, I just want to make everything highlighted this month because a lot going on with the solar system. So hopefully on January 13th, it'll be clear and you can catch the occultation of Mars between 9:13 and roughly 10:30 p.m. Of course, the moon's going to be pretty bright. Actually, looks like full moon on the 13th, so the moon will be really bright. Mars reaches opposition on the night of the 15th and 16th. A couple other nice events, January 17th and 18th, Saturn and Venus will be close together in the sky. Also on the night of the 19th, check out Castor and Pollux in Gemini and Mars because they should be in a straight line. One of the things that I did not highlight is January 31st at dusk when the moon will be below Saturn. So since that's just a few days after new, you know that Saturn is getting pretty low in the sky and will be leaving the skies pretty soon. Go to the next slide, please, Kristen. And then on the night of February 1st, another nice moon and Venus conjunction in the early evening. And Pete Zapatka, I think, is not on, but I put in February 9th specifically for Pete. I think he's the one that coined the phrase that Corvus looks mighty fine tonight. Well, Corvus isn't very exciting, but so that's the joke. But on February 9th, one reason I have Corvus in quotes is because Castor, Pollux, Mars, and the moon will make a little trapezoid shape that reminds me of the trapezoid of Corvus. And I'm not sure why I highlighted February 10th per se, nothing fascinating to see other than Mars is at its northernmost declination for the year and being near, still not too long after opposition. We're getting the best looks at Mars for the year, or yes, for the year. Best looks meaning highest in the sky. And Venus is brightest on February 16th. Next slide, please, Kristen. Actually, you can go ahead 2 slides. To the member photos from Aaron, we have the Moon and Venus conjunction back in January. And from Anish, I believe this is M81. And the reason I have question marks is just to remind people that when you post your photos on wherever, this came from Discord, please identify what the object is. I mean, M1 is fairly common and easy to recognize, but some of these other objects, like you'll see, are not quite as easy. Next slide, Kristen. Brian has a nice photo of the Eagle Nebula, M16. Next slide. And the Horsehead Nebula. Looks like, I don't know if Brian is on the meeting tonight or not. I'm guessing that a lot of that may be hydrogen alpha, the deep red, but I'm not an expert on that. Next slide. Rhine Nebula, nice wintertime favorite. And here's one that people probably are not that familiar with. At least I don't think I'm familiar with it, the Spaghetti Nebula. And you can definitely make out the spaghetti. The only thing that's missing are a few meatballs or so. Next slide. Nice image of Jupiter from John and one of the Galilean moons. And I didn't research it. I was wondering if the moon might be identifiable by the color of the object, because you can actually make out a little bit of a disk on it, I believe. Next slide. And also from Pete Zapatka, the Moon and Venus conjunction from January or so. And then that brings us up to other observations. I wonder if anyone has had any observations over the last couple of months other than the clouds.
I think Ken has
Cole.
his, yeah.
Yeah. You have an observation you'd like to report, Ken? If so, take yourself off mute. The only observing that I've been doing is just watching Jupiter as it passed across over the line connecting Aldebaran and Beta Tauri. And then Jupiter's now to the upper right of that. And as we saw on one of the slides here, Jupiter will be due north of Aldebaran sometime in January 30th. All right, any other observations?
I think
Eric Fisher?
Yeah.
Yeah, John, whenever Venus and Jupiter are at opposite ends of the sky, I wait for that night when I can catch them out of both corners of my eyes. And that happened about 3 weeks ago. I could look between them and see them. And that's my field of view. It'd be interesting to compare it to other people's fields of view. If, maybe people saw them further apart. I don't know. That'd be an interesting test.
All right. Yeah, good test. Good test of your fisheye vision there, Eric. And Ken posted something in chat, I believe it is. He says his microphone's not working, but he saw a wonderful solar pillar on the 9th at sunset. Wonderful red-orange color. Mike Miller, you have your hand up?
Yeah, I saw some fantastic sundogs this morning on my way to work. But unfortunately, they were gone by the time I got there, so I didn't get any pictures.
Yeah, that's the way it works out sometimes. All right, thanks everyone, and back to you, Kristen.
All right. Thank you as always, John. All right. I'm going to go ahead and go back to the PowerPoint I had. Give me 1 second here. All right. Okie dokie. Almost there. There's so many buttons to push. All right, should be popping up again.
That's high tech for you.
Yeah, seriously. All right, can everybody see? Are we back?
Yep, you're back.
Affirmative.
All right, awesome. All righty, so going on to officer reports. For myself, I don't have too much to report. I did attend a couple meetings before and after the holiday party. We had an executive meeting on November 20th. There was a WAGMAN committee meeting that was held on December 18th. Just recently, Mingo had a committee meeting on January 4th, so I'm sure Eric and Brian will be going over some of the things that they were covering and also things that they have had going on. Again, with the holiday party, it was a great time. We had a lot of fun. I'm also at the moment just trying to keep warm, and I've been doing some astrophotography. Brian had gotten me a new telescope for Christmas, so I've been playing around with it. I know, Rich. But it's been a lot of fun. I've been doing a lot with Andromeda. I took some pictures of the pillars. So I'm trying to get the hang of it. I know Brian's like the expert in the household, but he's been showing me a few things. Dave Rager has also been helping me. So it's been a lot of fun so far. I just wish, again, like everybody else, the clouds would go away and it wasn't like 5 degrees outside, but it's going well. The only other thing that I wanted to report is I wanted to, within, I'd say the next month, I wanted to have a policy and procedure committee. I wanted to start this last year right after I took the presidency. However, the person that was going to chair it, I do not believe they're going to be chairing it as of now. So I'm actually going to chair this committee. I'm hoping to get a few of the executive committee members to be a part of the committee, also the involvement with the observatory directors, just so we can update some things on especially the 3AP website, just with like, policies that go with the observatories, the club, anything like that. So it's kind of like the outside of the bylaws, like it's just kind of just the way maybe we're supposed to do like deadlines, stuff like that. So that's going to be coming here hopefully the next month. And I will let you guys know how that goes. All right, so moving on here. For our other officers, John, do you have anything that you need to report?
Speakers for the monthly meeting and not be the speaker for the monthly meeting, but this month didn't quite work out according to plan, in large part because there's a really big astronomy conference starting on Sunday, and anybody who had interest in a spring presentation definitely did not want January. So I've got people who are interested in February through May, but nobody officially committed to February through May yet. If you're interested in giving a presentation to the club, definitely reach out and let me know. Otherwise, if I can't manage to find anybody else, I've got other talks in the backlog, but I'll go longer. It's a threat at this point, right? I can do 75 minutes, 90 minutes, volunteer, so I don't have to bore you.
All right, you heard it from the horse's mouth, peeps. Either start signing up or find someone to start to sign up. But no, John, definitely a great talk tonight. So thank you for choosing that specific topic. It was very interesting. But yeah, please reach out to John if you know or if you would like to volunteer to be a guest speaker. We definitely appreciate it. I know the members really appreciate it as well too. All right, Rich Dolish, did you have anything to report?
Nothing specifically from recording secretary office. I did want to mention that I am doing the seminar for beginners at Mingo tomorrow. With the inclement weather, I will send out a notification by 1 o'clock if we have to cancel. So I'll be heading down to Mingo early to make sure the roads are plowed and we can get up to the observatory. And I'm able to contact the people who quote unquote bought the tickets from Eventbrite. I can send out a mass email to them too. So by 1 o'clock, we'll know if it's on or not.
Okay, thank you, Rich. I think down here and they were saying like 1 to 2 inches in accumulation for the day. So we'll keep our fingers crossed it stays
Yeah,
on the lower end.
it's supposed to be light, but just in case.
Okay. Dave Rager, I don't have my full screen up. Are you on tonight?
I didn't see him on the line there.
Okay. Alrighty. Gail, are you on tonight?
I saw Patrick.
Yeah, I thought I saw Patrick log on earlier. Oh, no audio.
Oh.
Okay.
Could I play through because I need to make a phone call?
Yeah, that's fine, Joyce.
Okay, I just would like to say that since it's been such a good period for observing, there's no reason that you all shouldn't give me a story about your own personal observatory or even your own personal telescopes or what kind of telescopes in general that you like. It doesn't have to be a greatly well-written thing. It can even just be notes because we can piece it together. As a copy editor for several years for a student newspaper, and Eric has edited more things in 40 years than most people live. But please consider sending something for the Guide Star since there's not going to be a whole lot of astronomy activity in terms of observing. That's all I have.
All right, thank you, Joyce. Okay, so we'll go ahead and keep going forward here. Terry Mealy, I think I saw Terry log on earlier. Are you still on?
I'm here. Yeah, I don't have anything special to report. I'll have the end of year and end of or the fourth quarter treasurer reports probably sometime this week or next.
Make a phone call, baby.
All right, sounds good. Hey, Joyce, can you mute your mic?
Oh, sorry. I thought I turned my whole thing off, actually.
That's all right. All right, thank you, Terry. Okay, Michael Scovrin, are you on tonight? Okay, I'm guessing not. Okay, we'll go ahead and move on here. All right, so I did get the names of our new members. These names all dated back from our November 8th meeting to today, just because, of course, we didn't have a report for the December get together. So these are our new members since, like I said, November. Right now, in total members for the club, we're at 496, which is pretty awesome. So hopefully with the change, this new year, we can hold some of these numbers. Hopefully everybody will renew their memberships, which I'll get to that real quick. But yeah, so there's a lot of names on here that I know I will not be able to pronounce correctly. So could I, pretty please with the cherry on top, get a motion to accept these new members into our wonderful organization?
So be it.
Okay, Frank, were you motioning? I'm sorry.
Yeah.
I'll second.
Okay, I have Frank and then Phil second. All those in favor say aye or give me a thumbs up. All right, are there any objections? Any abstains? Okay, Mike, I got your message. Yeah, Phil seconded it. La la la, if I can talk. All righty, so we'll go ahead and move on here. Thank you very much, everybody.
So we have to find 4 more members to hit 500.
Yep, 4 more members.
So go out and recruit everyone.
But you know, I think, wasn't it the November meeting or the October? I said I wanted to hit 500. Like that was the goal. So come on, guys. We just need 4 more.
Almost there.
Yeah, but seriously, 496. That is very awesome, guys. Sky is not the limit. Sky's not the limit. All right, so let's go ahead and move on to observatory reports. I believe I think most of the directors are on. So Eric, we'll go ahead and start with you. What's going on with Wagman?
Okay, nothing much, nothing. No, I'm in fact, a lot is going on with Wagman, but for the sake of time tonight, I'm just going to sort of give you some bullets, and we'll publish this in the Guide Star in more detail. We had a meeting with Allegheny County deputy directors. They do not have a director right now, just deputy directors. A very good meeting at the observatory on a cold and blustery afternoon at Wagman. And the main takeaway that I got from the meeting is that they are agreeable to installing a parking lot on the east side of that hill. If you remember, on the east side where the rain gauge is, it drops down and there's a plateau. And they are okay with putting in a parking lot there and an access road to solve our parking problem at their expense. And even though it's not within the least boundaries of our observatory. We're dealing with the floor of the Brashear room. We're debating whether to replace the whole thing or just do repairs. The consensus seems to be to replace the whole floor. So we're also looking at putting in a paved lane behind on the north side of the building to solve a water problem that came in the Brashear crawl space. We've got part of the Starlink system installed. If Jody, are you online? Do you want to just give a quick summary of what's going on with Starlink? Are you there? I thought I saw him.
Yeah, I think he was on earlier. I don't know if he might have logged off earlier.
Anyway, the antenna's up there. Some brave souls got up on a ladder 20 feet in the air, including Rich Dawes and Mike Scovern. It's in the Guide Star. We have to put some electronics in the membership room, but it's coming along well. Just to give you a quick rundown of some of the improvements that we're looking at this year, we're going to put monitors in the reception room, kind of like what Mingo has, to show astrophotography of club members, like photo contest winners, also messages of the night, what's coming up, what planets are visible. We're going to convert the membership room into more like an employee's lounge and make it more relaxing, like the Mingo warm-up room with a couch. And let's see, we're going to have possibly a lending library in there of books. We're going to put new rugs in on both rooms. And what am I missing? Oh, yeah, we're going to put 200-watt floodlights on the outside of the building so people can see what they're doing.
Phone hit your head.
I'm just seeing if you're paying attention.
Those are going to be red floodlights, right?
Any other Wagman committee members? Like Phil, you want to say anything about the Mankin telescope, for example?
Not at the present time. Waiting for another nice, clear, warm night to work on it.
How about July?
We want to be done before April.
Right. Any other Wagman committee members want to make a comment? Otherwise, that is my report for now.
Hey, Eric, what's going on with that sign that they were putting up away from Wagman? I don't know, where was it at, down in Cheswick or somewhere?
That sign is below the ridge of the hill, so we're going to see secondary light from it potentially. But that's already a kind of a light polluted area anyway. I don't know that it's going to affect us that much. Fortunately, it's not in a direct line of sight, as far as I can tell.
Is that stupid billboard in Tarentum? that we're
Yeah.
talking about.
That's
Yeah.
it's also part of that new interchange where the lights they're a lot brighter, but they are facing down, so it's
Yeah.
kind of both.
But it is below the ridge line, so we won't get the direct light.
Good.
Okay, Kristen, I think that's all I'm getting from the guys. I got a great bunch of people on the Wagman committee, very smart. Like I said, the Guide Star, they do the work. I just write emails.
All right. Well, thank you, Eric. Glad to hear things are going really well, and definitely getting a lot of emails. And I'm very happy to see that you guys are working out very well. You guys got a very nice team up there. So,
By the way, if you want an exciting experience, go up to Wagman on a day when it's cold and snowy and blowy. The wind coming from the west gets going real fast over that hilltop, and we get snow devils over the hilltop. You know what a dust devil's like. We get snow devils because that hill is so high. So if you want any excitement, try that. Thank you.
well noted. Well noted. All right. Well, let's go ahead and turn over to Mingo. Brian, you want to go ahead and give your report?
Sure, there's also not too much to go over at the moment. Starting with the Mingo 20th year anniversary, the date has been chosen. Shelter 10 has officially been reserved. I got the receipt a couple days ago from the park, so everyone save your date, August 9th, 2025. It's a Saturday. Will be Mingo's 20th year anniversary. There's going to be food. There's going to be possibly guest speakers and about, members that have been there since the beginning. Trying to put together a video. So some of you might be reaching out to see if you want to be a part of that video. So once again, August 9th, more details to come as the committee hashes them out. Kristen had mentioned that we held our first committee meeting of the year. We did. I like to hold them early. That way we can get the vote of confidence out of the way. And I'm happy to report that there is no changes of leadership at Mingo. So myself, Heather, and Michael Metney will continue as director and associate directors. The last thing to go over is most of you may have already known about our 2025 non-maintenance project at Mingo. We are remodeling the planetarium this winter. With that, we are revamping the entire room, so it'll be a better experience for not only our guests, but our guest speakers. It'll easily allow us to live stream and record the guest speakers, and a couple other little nifty things that we're planning on doing. With that, we've already started getting bids to replace the carpeting. Due to the odd size of the planetarium, we're also going to explore the option of recarpeting both telescope rooms at the same time. Otherwise, we're going to have to hang on to a 11-foot by 25-foot roll of carpeting until we decide to do it. So more details on that. We're definitely going to be requesting some help because so far the quotes for the carpeting that we've received, we do have to remove the old carpeting. So we'll need a couple strong individuals to come in there and help rip it out and scrape it down and remove everything out of the 3 rooms. But I think that's all I have for now.
All righty. Thank you very much. And if any of the committee members from Mingo are online as well, I know John Stump. Again, thank you so much for helping and being a part of a really good team as well. So I'm definitely looking forward to 2025. I think it's going to be a really good year. Okay, so moving on here. Old and new business. Again, holiday party was definitely a success. I wanted to give, of course, some shout outs. Thank you very much to all the executive committee members and Mingo and Wagman committee members for helping and volunteering to make the party very successful. Also, I know Dave's not on right now, but his wife, Reagan, catered some food for the party. The food was very well received. We actually did have a good bit of food left over, and thankfully, we had 2 pans. I think one was like pasta, one might have been green beans, or 2 pastas, I forget. But they were untouched. And since Reagan is a certified food handler, Jody Farr's wife was able to get in contact with I believe it was like a veterans home, veteran shelter, and Jody's wife actually dropped the food off for them that night. And according to Jody, he texted me the next morning and told me that the manager supervisor of the building was in tears when they received the food. So we were very grateful that, some of the food that was not used, we were able to donate. So again, a big thank you. And also, a thank you to Reagan for committing her time and also volunteering to make the food, because everything was delicious. I know Rich had mentioned, for those of you that maybe missed it, the end of the year awards for the Nova, Lindblom, Harrison, and Brashear went to those individuals. I had forgotten to also list Tom down. He did receive Director Emeritus for Wagman. Another thing with old business, I know I talked about this during the November meeting. I really do want to try to get some ideas going for the club's 100th anniversary. I know it seems like it's a few years away, but I feel like it's going to sneak up really fast. I'm honestly looking for anybody who wants to volunteer. You don't have to be a committee member or an executive committee member or a director. If anybody wants to volunteer to, talk about, where we could have this, what kind of event do we want to have? Do we want to dedicate or have a theme for it? Also, a lot of members I know have so much history with the club. I know everybody has pictures, everybody has newspaper articles. So, trying to bring everybody together and maybe get some things organized or come up with a plan, I think would be a great idea. So it doesn't have to be a formal committee, for this year, but if anybody wants to start hashing out ideas or, might be interested in being in this group, then, please let me know. Eric, I see your hands up. Go ahead.
No, I'm raising my hand to be in that committee, and I've already started to talk to some of the old timers to start looking through their boxes of correspondence and newspaper clippings, and we have some gaps in our history to fill in, and as best we can.
Yeah, that sounds good. Like I said, I know this is going to be pretty big. There's so much, just history in the club. I think it's going to be a rough one, just trying to narrow down what all we want to, cover. Obviously we want to get some major things in there, but you don't want to leave out the little things either, because, those are milestones just as much as the big milestones. So, yeah, if anybody is interested, or, if you have, like I said, pictures, videos, anything like that, please send them our way, send them to Eric or myself or Joyce, anybody. And then, like I said, if anybody has ideas for venue, or also, if we want to do a big theme, or, maybe even get a huge guest speaker. And if we wanted to do a guest speaker, just any ideas that you may have. I feel like this is something that shouldn't be planned by one person. I definitely want the club to be involved, all the members. So please let me know. And, hopefully, I don't want to wait until we get too close, but as we get closer, we'll start to really form a committee. That way we can get everything organized. All right. So new business. I said this earlier, just a big reminder, make sure you renew your membership. I know there's some of us that maybe keep on forgetting, or, it just slips the mind here. But I believe the grace period will end January 31st. So February 1st, if you can't log in to your 3AP members page, or if you're not getting the Guide Star anymore, or if you're not getting emails from the club, or even being on the list server, that's going to be why. So just a big reminder to everybody, please renew your membership and also get the word out, your friends, family that are also in the club. I just wanted to also throw this out here. I can't remember, Brian may have mentioned this at the November meeting, but the 3AP is going to be at NEAF this year in April. So for those of you that are familiar with NEAF, it's a big astronomy event in New York. I believe it's like 2 or 4, it's a weekend, I think. Brian, I know he went last year, but they did get several members to be like representatives for the 3AP. So, if you guys are heading up for yourselves, if you bought tickets, look out for the 3AP up there because they're going to have a table. So lots of exciting things. Another announcement that I wanted to make was the 3AP and offsite star party schedule is now on the website and it's on Discord for the event. So for those of you who, if you did get star party cards at the holiday party, I know they were distributed to the directors, so they have those as well too. However, if you need to check your calendar because you're trying to plan for, summer, spring vacations, and you're like, when's our star parties? They are on the website. And Eric, I don't remember if you mentioned this when you were talking, but did you mention that Wagman's doing solar?
Oh yeah, I forgot to mention that. Yeah, this year we're going solar at Wagman. We're going to be opening up not less than 1.5 hours before sunset. And I know we don't have a hydrogen scope like the Lunt at Mingo, but we do have a white light filter on the Bashir, and members have their own H alpha filter. So we're going to be doing solar observing that allows us to get cars parked and people positioned and blankets laid out in sunlight rather than darkness. So that's a big change for Wagman. And it's going to be real simple. It's either going to be the top of the hour or the bottom of the hour. No, 8:17 p.m. or 9:14 p.m. It'll be very easy to remember the numbers. And they will appear in the Guide Star. I told Joyce to put them in the Guide Star for Mingo and Wagman, the start times.
All right. Thank you, Eric. I figured I'd mention that just in case we forgot to. But yeah, so Rich, did you have anything? I know there were a couple of I'd say the bigger offsite star parties, like that was getting on the calendar. Are you still waiting for anybody else to make a date so far, or has the majority of them come in already?
There's still some people that I'm waiting to hear from. We have Mike Christensen has set up a couple of the state park already. Hillman is a popular one. That's actually going to be in spring this year. I reached out to the UPMC Heart Camp for kids. We did that last year for the first time, but Eric did the presentation. We got clouded out. He reached out and said he'll be setting the date soon. Also with UPMC, there's a sibling bereavement camp that we have on the schedule for this year. That's a new one. They reached out to us the end of last year, but they reached out late and we couldn't schedule anything with them. But we're doing that this year. Bethel Park has 2 on the schedule this year. And Chartiers, Houston, Bridgeville. So we have quite a few. We're going to have a busy season.
Lots of stuff for the offsite committee, huh?
Yep.
Yep.
And volunteers are needed. So please come to as many offsites as you can.
Plus guest speakers, right, Rich?
Absolutely.
All right. Thank you, Rich. Okay. One other thing before I'll do a quick open floor if anybody has anything. John, I saw your email right before the meeting, so I added it real quick to the PowerPoint. So John did put out an email on the list server. I hadn't had a chance to put it on Discord because I like literally just saw it before I started the meeting. But there is a swapping date for January, so January 31st. It's at Axis, is correct? Yep.
Yes.
All right, so Matt's allocating at 7:30 a.m. I believe John has said to please RSVP to him so he can get a head count so he can contact Max's to let them know how many people were coming. So thank you, John, again for coordinating this. Much appreciated. And then, yes, please let John know. And I'll put it on Discord. That way the Discord folks will know.
Yeah, I still haven't gone on Discord yet. That's on my to-do list.
Okay. Just let us know anytime you're up at one of the astronomy event. Actually, if we end up going to Max's, maybe we can get you signed up while we're at the restaurant.
Whatever. I'm gonna try to do it myself, though.
Okay.
I'm supposed to know high tech. After all, I worked in high tech for years and years, but that was back in the Miocene era. So,
So no excuse then. No excuse. All right. I believe that's all I had. Since the holiday party, I'm sure more stuff is going to come up as things, either thaw out or, we start having more events. I'll just open up the floor real quick. Does anybody have anything that they need brought up or any announcements?
I had a question about the Allegheny Observatory lecture that I think is going to be on the 17th. I was just wondering if anybody was attending it. Because I haven't seen anything on Eventbrite about tickets for it.
Yeah, the last time I went on that site, Rick, they had no events written down for the year. They had not scheduled any guest speakers, and you'd think they'd at least do it in January.
Well, I went to the University of Pittsburgh website, and it seemed that they have the meetings listed, but like I said, you need a ticket from Eventbrite to attend. And I called the number on the University of Pittsburgh website, and that was a couple of weeks ago. No one's bothered calling me back. And
no, what you do is you can just call the observatory number. These tickets are free. They only have limited seating. That's
I know, I've gone to a bunch of them, but like I said, there's no. I've searched on Eventbrite off and on for the last month.
Right.
Nothing shows up.
Those lectures may not be on Eventbrite. Call 321-2400 and they'll just get you in the room.
Well, it says on the university website that you have to get tickets from Eventbrite.
But on the observatory website, it says something different. Their left hand doesn't know what the right hand's doing. If you go to Allegheny Observatory website, there are the lectures and the seating requirements.
Do you know what the telephone number is by any chance?
412-321-2400.
412, I'm sorry,
321.
Okay.
2400.
All right.
And you'll get a gal named Carrie Handron. You just say, hey, I want a seat for the lecture. That's just so we don't get more people than we have seats there.
Yeah, I know. But like I said, for the last 12 months, I would go to the Eventbrite site, get a ticket, and you just do a simple search, or it usually would show up. But nothing.
Looks like they're up now, Rick. I just did a search. I saw a couple listed. Looks like January is sold out already.
Yeah.
Oh, bummer.
Yeah, well, it's hard to get a ticket when they don't, when it never shows up.
Yeah.
So, all right.
Well, you don't have to show a ticket walking in the room. You just have to have a seat reservation.
Yeah. Okay. I just don't understand why they make it so difficult.
I'm not surprised that they make it difficult.
All right. Did anybody else have anything? Any other announcements or any concerns, anything like that we need to bring up?
Yeah, I'm still griping at trying to get on that guide store.
Yeah, you got to get your Adobe updated, Frank. You got to have them download a fresh Adobe Reader. Apparently, that's what Heather said.
I'll have to get my IT person downstairs to get it up for me. Or catch that little young girl down the street and grab her.
Don't go grabbing young girls, Frank. That's not well tolerated.
Ask her.
That's what it is with this new age. It wasn't like that in my day.
Yeah.
It's a good thing this discussion's not being recorded and put out on the internet.
Yeah, or streamed on YouTube.
Right.
By the way, Kristen, just for a quick reference, in 1980, for the 50th anniversary, 1979, we had a banquet for the 50th anniversary, and then we had one for the 60th anniversary. So a banquet was part of the previous two anniversaries. We did not want to do one for 75, and we just took a big cake up to Wagner that had a big 75 on it. So.
Okay. Yeah, like I said, we can keep some ideas in mind, and I definitely would like everybody to give their 2 cents. I definitely want everybody to celebrate. Hope we have like a really big turnout because it's a big one. It's
right.
Number 100.
Brian Crawford, are you still on?
Yes, I am.
Yeah, I know I'm a nag about this, but we have that really nice metal etching of the 2017 total eclipse over there in the corner of the planetarium by the door.
Yes.
Just make sure that's preserved for the remodeling because that was donated by John Payne at some expense.
Oh yeah, we're not going to get rid of that.
Okay.
I don't think we have any plans on getting rid of any of the photos. The only thing we had discussed of getting rid of or refreshing is the poster boards.
Right.
Kristen, I might offer you a suggestion about 100th anniversary. We have a banquet for the Christmas party in December, but if we had shall we say, an outdoor banquet, or i.e. a picnic, say in one of the parks, in the summertime, when it's nice weather and warm, like in July or something, it might be something to think about. I'm a secretary in our car club, and we have a spring picnic at one of the groves in North Park, and that's always quite a hit. But you might think about that sort of a option. Okay.
Yeah, sounds good.
Summertime, just shorts and weenies, and well, we have it catered, and that's just an idea.
All right, sounds good. All right, so I think that about covers it. I think we can go ahead and adjourn the meeting. Thank you, everybody, for joining tonight. Can I, Chuck, I think you need to mute I'm getting like feedback, or Frank, somebody. There you go. Thank you. All right, can I get a motion to adjourn the meeting? I see Eric's hands up, and then Patrick. All right, all those in favor?
Aye.
Aye.
All right, any objections? Any abstains? All righty. Thank you very much, everybody. And John, if you're still on, thank you again for being our presenter tonight.
Excellent
I hope,
talk.
yeah. I hope everybody stays safe and, be careful with the snow and the cold. And hopefully these storms and clouds will go away, and hopefully things in California will turn around as well too. So definitely positive thoughts for them.
Yes, I think Mount Wilson Observatory was saved.
That's good.
Yeah, I saw that yesterday. They said their staff is still there. They were, the fires were put out before they did damage to the observatory. Oh, what a thing, Ooh. So
Okay, thanks a lot, Kristen. Good meeting.
Thank you.
Thanks,
Thank
everybody.
you all.
Yes, Rich, let me know if anything goes on at the VA, okay?
Absolutely, Mary.
Yeah, because I always like to get up there.
Good night, everyone.
Thank you.
All right. Good night, everybody.
Thank you, everyone.